Hi everyone, in this video we're going to see the technique of integration which is from chapter 5. But in this video I'm going to explain the technique of U substitution. Let's see the further information. Integration by substitution. Here we are going to see the learning outcomes. The learning outcomes important to students because before we go further to the topics, it gives some imaging or information that what we're going to learn in this topic. So first, we're going to evaluate indefinite and definite integrals by using U substitution. Indefinite integrals is there is no x value stated. But when it's going to definite integrals is the x value is stated, so we have to substitute the x value that given in the question. After that, the second is use definite integrals to solve application problems. When it comes to problems, we have to use definite integrals because indefinite integrals is cannot use because there is no x value stated. And third is use integration by substitution to evaluate integrals. And the last one is we're going to communicate mathematical ideas using correct and appropriate notation. Thank you. We're going to see further in this video. In this slide, we're going to see the meaning of integration by substitution, which is known as U substitution, or another word is the reverse of the chain rule. Okay, the reverse of the chain rule is the thing we the derivative of composite function is, and then we will get the outside derivative times with the inside. Then by performing the integration, if we integrate this thing here, we will get the same thing. So f is antiderivative of f, where f prime equal to f, so we get this equation. Let's see the theorem. If u equal to gx is the differential function whose range is an integral L and f is continuous on L, then we get this thing. If we integrate this, which also same as this, so we get the final thing is this function of u plus c. And last we have to substitute u with the questions. Let's see more example. Let's see the u substitution, which is multiplying by a constant. This is the example of the question. So here we have only u, but there is no derivation of this u. So how we can get the derivation of this? So we have to multiply with the constant. This is the constant and the function. So we also can bring out the constant out here and write the function inside here. So we will get 1 over 8 times with 8. So if we cancel out it, we would not change the real meaning of the function and the question. So the u is equal 8x plus 5, and then du per dx equal to 8. So we bring the dx to here. And then we substitute the u. By bringing the constant out here, we change the square root in the form of the power. So here u is power plus 1, we will get 3 over 2 divided by the power 3 over 2. So we bring the 3 over 2 up there, so we will get 2 over 3 here. Then we times with the 1 over 8, we will get this. And then at last we substitute u with the 8x plus 5. In this slide, we're going to see how to do the u substitution of rational function. This is the question, and we identify the u and the du. The u is equal to x cubed plus 3, and then du per dx is 3x squared. So we bring the dx to here and we get this. So we substitute u here, which is this. It also can write as u negative power of negative 2. And then how we get the negative here is with the power of this plus 1. So we will get u negative 1 divided by negative 1. So we will get this. We must add the plus c here because this is the indefinite integrals. After that, we substitute u with x cubed plus 3. And these are the answers. In this slide, we're going to see the u substitution of logarithm. This is the question. So here we have to identify the u and the du. So here the u is ln x, and then the du is differentiate of the u. So we get 1 over x, which is the dx bring to the opposite side, so we get du equal to 1 over x times this dx. So the integration of this, we will get 1 over u du. So we cannot take it the u as u power of negative 1 because this is the logarithm. So we have to, if we differentiate this, we will get ln u plus c. And then we substitute u back here, and then we will get ln, and then ln x plus c. This is the final answer. After this, let's see the u substitution of exponential. This is the question. So we identify the u here, which is the x square. And then the du per dx equal to 2x and du equal to 2x times with dx. And we write in the question back. Then we substitute u inside it. The exponent with u, this thing is equal to du. And then when we integrate it, we get exponent u plus c. After we get this, we substitute u back with the x square. This is the final answer. Let's see some example of definite integrals. These are the questions. So as usual, we have to find the u and the du. So in this question, the u will be x squared plus 1, a plus x, and then the du per dx is equal to 2x plus 1. So we bring the dx to the right hand side. So we will get du per dx equal to 2x plus 1 dx. To solve the question, we have to write the question back. And then we substitute u. After that, we integrate the u. We get u squared over 2, which is from u1 plus 1 over 1 plus 1. Then we substitute u with x squared plus x. So there's no place, we bring it there to the side. So as usual, we solve this. This is the 5 years. and this one is for the x equal to 1. So for this we get this, and for this we got -2. So final answer is 448. We must substitute the 5 minus with under x equal to 1. Let's see more examples of definite integrals. These are the questions. The limit is square root 3 over 2 and the 0. So we have to identify the u and the du. The u would be sine -1x, and then the du over dx will be 1 over square root 1 minus x squared, and then we bring the dx here to the right hand side, we will get this form. After that we substitute u into the question, and I think you have the question how come the pi over 3 will be here. Let me explain you. When we get x is equal to square root 3 over 2, the u will be pi over 3. How we get this? From the triangle here. Here is 60 degree, and then the pi over 3. When here is 30 degree, it will be pi over 6. So here is square root 3, here is 2, and here is 1. When it is sine graph, so we get, when it's 3 square root 3 over 2, we got pi over 3. That is how we got pi over 3 here. After that, we integrate the u, like u 1 plus 1 over 1 plus 1. So the u is u square, and then we bring out the 1 over 2 to the outside here. Then we substitute pi over 3 inside the u. When we get this, when we square root the pi, we get pi square, and then 3 square is 9. So 9 times with 2 is equal to 18. So the answer is pi square over 18. In this slide, we're going to see the application in our daily life. Things that we learn or relate to our daily life. In this picture, it shows the swimming pool. So how much the water refill here? So how we going to calculate the amount of water refill here is by using some technique of integration. First, we have to see the shape of the swimming pool is irregular. There are more curves here and the ellipse shape. So we have to find the gradient, the slope of each part, and then use the integration to find the volume. The volume of the swimming pool is equal to the water to refill it. So the all application that we learn in this video relate to our daily life. It's a science of the calculus. We reached the last part of the lesson. Here are a few questions that is related to our topic, which is indefinite integrals and definite integrals. The last there got one link of quizzes. You may try it and have fun with it because it have music. We encourage you to answer the question because it is in the form of game. I hope this video brings you benefit to this chapter. Thank you very much for watching this video. Thank you.